do we have?
20.
Okay, 20 is a good number to start. So from our recap, what we did yesterday. Yesterday we learned about the different types of switches that I was talking about. So there were a lot of switches I was talking about. We spoke about the maintain type of switches. We spoke about momentary type of switches. We talked about single pole, single throw, single pole, double throw. And we spoke about the different types of switches that we have. For those of you who were not here yesterday, we learned about a form A switch, form B, and a form C. And this is very vital because this knowledge, we're going to take it and we're going to apply it in all the other things that we're going to do. We learned that for form A, one of the identifying factors that you can know that a switch is a form A switch is when you look at A, there is an opening here. So definitely if I have a switch like this is the common, this is the normally open. Because this is open, that tells me this is a form A type of switch. Then when I go here, because these two are touching, that is closed. So this is a normally closed switch. And as a result, it's known as a form B switch. Then we have this as well. This is a normally closed, normally open. Now, once we have an open and a closed switch all together in one, we call it a form C switch. So this is a form C, as it's here. And we found out that you can apply all these things in different types of switches. Pretty much a switch is an input device, and we're going to learn more about that. Yesterday we learned about different types of mechanical switches. We learned that switches that do not maintain their state are called momentary switches. And the ones that maintains their state are called maintain switches. So what is an example of a maintain switch? Let's take a look at this switch, for example. When I press here and I hold it, it stays in that position, and it's going to stay in this position for as long as it is. If I want to change the position, I have to manually toggle it, like these ones. I have to toggle it, and it's going to stay in that state. And if I want to change the state again, I have to press it. So these are maintained switches. What about momentary switches? Let's look at one like this. They look very identical, like that. Right? This one is going to stay where it is. But look at this one. When I press and hold, it's going to move. But once I take my finger off, it's going to go back to its original state. So as a result, this is called a momentary switch. Okay. But this switch, because it's got three, it could either be a single pole double throw, or it could be a single pole single throw. Depends on what it is. So we can have one of these that got two terminals alone. It's got an off and the on state that is identical to something like this. Right? We would have the off state, which breaks the circuit, and the on state, which is going to make the circuit. That's just what it is. We also were looking at some of them. Look at this one, for example. When I press and hold, it stays in. But when I take my finger off, it comes back up. So this is the default state. So this switch is called a momentary switch. That's just how I can tell. And for me to be able to tell whether it's in the open or the closed state, I need to take the digital multimeter, connect it to these, and then I would be able to test. Now, having said that, we're moving on to what we call electromagnetic switches. Electromagnetic. It's just telling you that these switches are controlled by a magnet instead of mechanical switches. So unlike mechanical switches where you have to physically push up and down. These switches, called electromagnetic switches, are controlled by magnets. So let's take a look at some of them. These are electromagnetic switches. So this is one of them. You can see it's got only 2 pigtails coming out of it, but it needs a corresponding magnet. So once I bring this magnet closer by, it's going to make or break the circuit, right? Remember, with these ones, I have to physically toggle it like this. But these ones, for me to change the state, I need to bring a magnet close together or separate it. These ones are recessed, meaning that you have to make a hole and insert them into the door frame. We have the surface mounted ones as well. These ones, once you bring them together, it changes the state. Once you take it apart, it changes the state. The ideal and the normal state is when they are apart. Okay. So when you want to test the default state of this, don't put the magnet close to it before you test. Keep the magnet away and test it. That will tell you what the state is in. We learned that you can get switches in a form A, a form B, or a form C. It is in a similar fashion you can get these magnetic switches either in a form A, a form B, or a form C. So let's take a close look at this one. This one has 2 terminals, here and here. So definitely it's either a form A or a form B. I cannot tell just by looking at it. What I have to do is I need to grab a digital multimeter and put that to the test, and we're going to see how. Now let's take, thank you. Let's take another one. It looks identical. However, look, this one has 3 terminals on it. And this is a form C because it would have a normally open, a normally closed, and a common. And we're going to test these ones as well to see which one it is. So now we've seen the 2 types. We've seen a single pole, single throw. We've seen a single pole, double throw. And we are going to look at one that is a double pole, double throw. I think I kept it here. Let me just grab that for a second. Here. So let's look at this one. This is a double pole, double throw recessed. Let's count how many wires we have here. We have the white, we have the red, and we have the black. But on this other side, we also have the same thing, white, red, and black. So we have 6 wires. These ones on the right would act differently from these on the, so these are 2 circuits that are in. What is going to happen is, when I bring this magnet closer like this, it's going to activate both switches in to behave the same. So yesterday we were looking at this. We had the opportunity to look at this yesterday, where we determined that if we have this common, normally closed, normally open, and we have the same thing like this, normally closed, normally open, and a common, like this, right? These 2 arms are connected together. So these are 2 separate circuits that are here like this. This is a common, that is a common. Right? So what is happening here? Sorry?
Sorry, it's making noise.
No, don't worry. You can continue doing that because I have the mic here, so it's fine. Yeah. So because I have these, look at how they're going to act separately. I can decide to use this here as one circuit, and I can use this here as another circuit. Meaning that I can decide to put or connect this one to something, let's say an access control system. and I can connect this to my alarm or burglary system using one contact. So this is what is going to be on the door. When the door closes, it's going to show the system that the door has been closed. And I can send this to my access control system, and I can send that to my burglary system just using one system. And this is a double pole, double throw. Any questions? So before we continue, let me see those who are in the house. It's very important. Right, let's do the register. Country of origin. Let's see who is first. Yesterday was Ghana that was first. Let's see who is first this time.
So Kenya.
Kenya. Today Kenya wins.
Kenya, Gambia, Canada, Ghana,
Guinea, yeah.
Ghana, Gambia, Burkina Faso as well.
Oh, Burkina Faso is here. Who else is in the house?
Somalia.
Okay. Anyone from Russia?
UK, Brooklyn, I think New York,
Okay.
Ghana, Sierra Leone, Jamaica, Colombia as well.
Yeah. Okay.
Nigeria, Ghana.
Nice. So we got diversity, which is good.
Uganda as well.
Good. We got Uganda. So this is a double pole, double throw. So now you understand that when it comes to electromagnetic switches, you can get them in a single pole, single throw, single pole, double throw, and a double pole, double throw. So we're still building our case as and when we are going. How does these door switches work? They work based on the principle of what we call a reed switch. And a reed switch is a type of switch that has two metals encapsulated in a glass. Right, that's just what it is. Two terminals encapsulated in a glass. So when you bring your magnet close by, based on how it's designed, it can either force this terminal to go touch that. Right? Very simple construction. I bring the, when it comes to magnets, like poles would repel, unlike poles would attract. Right? Bring positive and positive, they go away. Right? That's just what's going to happen. So based on the material they were using, when you bring the magnet close by, it could try and repel it, so this would bend and go make contact with that. And as soon as you take the magnet away, this comes back to its original state. And we call these type of switches a reed switch, R-E-E-D switch. That's pretty much what they use. On the other hand, these ones, they have them in very diverse formats. So you can have one that is an industrial switch. So something like this. It's industrial. They use them in a lot of commercial spaces. So when you have an overhead door that you want to monitor, you can directly bolt this to the floor, and you can have the forklifts or the trucks drive over it. Nothing is going to happen. So if you're doing any work in the warehouse and you need to monitor the door, you can put one of these. It comes with a long pigtail. These ones also do come in a single pole, single throw, a single pole, double throw. So when you're going to buy, you have the option. This one that we have here is one that is made by Amseco. And they come differently. You have to know what you're looking at. So the packaging looks pretty much the same, but when I flip it over and take a look, you know what, I got to take it out. So this is a new package. Just going to rip it open, take the contents out. And I'm going to rip this one out too. So these are all brand new. When you get the package, they come with the magnets in it already with the mounting bracket. So you can see this is the mounting bracket and it's got a magnet already bolted on. So when you install this on the ground, you're going to attach this to your door. When you open your overhead door, the overhead door is going to travel with this. So travel all the way and there's separation. When you close that overhead door, the door is going to come all the way down and make contact with this. In a similar fashion, if you have a sliding gate that goes back and forth like this, you're going to bolt this one like that and attach this to your travel gate. It's going to open, detach, and then sends a signal to your panel that the gate is open. And once the gate closes, this is going to align back and send a signal to your panel that the gate is closed. So these are some of the ones you can use. They're outdoor proof, they're weather proof, and you can use them. Most importantly, let's look at how many pigtails we have. We have 3. 1 red, 1 black, 1 green. And it just goes to tell me this is a single pole double throw. Now let's take a look at this other one. It's got only 2 pigtails, a green and a black. So this is a single pole, single throw. But I would not be able to tell you whether it's a form A or a form B without having to use the digital multimeter to test for it. Any questions so far?
Not really, but somebody was saying like a roller shutter.
A roller shutter, yes, you could use that. But you know, here in North America, in the warehouses, the way our garage doors look is the garage doors will roll all the way up. That's how they open. So you open it, it goes up, and it comes down. So you could use that. And we have a lot of sliding gates as well. So you want to see whether the gate closes or the gate opens. It's one of those sliding gates. You can use that. If you have a swing gate, also that opens like this and comes back, you always want to monitor whether the gate has been fully closed. So you mount the one with the magnet onto the travel. So if this is your fence wall, you're going to mount the contact, which is the switch. This is going to remain permanent on the permanent fixture. And if this is your gate is going to swing. And then when it comes back, it's going to align with this. And the system knows that the gate has been closed. The gate is in position. That's just how it works. So for any input device or any switch, it's going to follow one of these, either a normally open, normally closed, common, or a normally open and a common, or a normally closed and a common. Okay, so these are the type of switches that we have. We spoke about the type of switches which are electromagnetic switches. And they are used for door sensors, etc., etc. But we have another one too that looks exactly like this. This one is not an electromagnetic switch. This is a mechanical switch because this ball in here goes in and out. So with this, you're going to install it between, the hinges of where your door is. So if your door closes, then it's going to force this to go in. And when your door is open, it's going to force this to come out. That's just how this one works. So this is a mechanical switch. And this is an electromagnetic switch. So we're going to do some tests, and we're going to see how these ones work. I'm going to grab the digital multimeter, and we're going to test a few things. So I'm going to do that at that table.
Okay.
Yeah. So first of all, I'm going to talk about this type of switch. I think the scissors is there. Pass it on to me. Yeah, thank you. So the first thing I'm going to work with is this type of switch. How am I able to determine the state of this switch, right? So I already have the pigtail. To be able to use the digital multimeter, I need to free up my hands a little bit. So I'm going to take the splice connectors and connect one of them here. And I'll connect the other one here. So two connected to that. And I'm going to take this, connect it to one end. And I'll do the same thing on the other end, like this. So this way I've been able to connect these with my hands free. The next thing I'm going to do is turn on my digital multimeter. Because I'm testing for continuity, I want to make sure that I set this to ohms. This multimeter that I'm using comes equipped with the beeping function, so I'm going to select that. Right away I can hear the beep. I haven't done anything to it. Means that the loop is closed. So let's see, if I want to change this state, and this is not faulty, I just need to grab a piece of magnet. It could be either that magnet or this magnet, and I'm going to bring it close by. When I bring it close by, I'm expecting the noise to stop, the circuit to be open. So let's take a look. See, I brought this close by, it's still beeping. Nothing is changing. It doesn't matter what magnets I bring. It's not. So right away you can tell that this is a defective contact, right? So I'm going to take this out and I'm going to grab another contact, like this one. Remember, this is a mechanical one. It's new, so you still see the pigtails are still covered. I'll take one of that, connect it here, and take the other one and connect it here. Now this is connected. I see there's an open line. But because this is mechanical, I have to depress that in. So let's see what happens. So by depressing it, I can see on here that there is pretty much no resistance on this entire loop. And that's going to beep. Once I take my finger off, the beep is going to stop. Because this is the default state and there is no beep, this is a normally open switch. All right. So I can conclude that this is a form A switch because it's open by the default state. Now I'm going to grab a next one. I'll put that aside. And I'm going to take this one here that has got 3 pigtails. So this one is a little bit tricky. First of all, we have to determine which of these terminals is the common. After I have identified my common terminal, I'll be able to determine which one is the normally open and which one is the common. So to do that, if I don't know, I'm just going to take one random one. So let's take the red one. I want to expose some of the copper, or this, in this case, this is aluminum. So I want to expose one of them first, and I'm just going to connect it to the black terminal, my black probe. So I have another one that is free. This is what I'm going to do. I have these 2 pigtails. I'm going to touch this one. I get a beep, right? And I'm going to touch the next one. There is no beep. But this doesn't tell me that this is my normally closed and normally open, right? What I'm going to do next is I'm going to switch them. I'm going to take this from the red See, this had a beep. I'm going to take this from the red and I'm going to connect it to the green. And see, I connect it to another one, which is the green. I'm just going to go ahead and expose the sheeting a little bit. Okay, this is off. And this is off like that. Okay. So I've exposed it. I'm going to connect this to the green like that. And again, I'm going to repeat the exercise. So I have two of them. There is nothing. There is nothing. See, I touch both of them. I'm not getting no beep. So definitely this one cannot be the common. So I'm going to take this and I'll put it on the black. Now it's on the black. No beep. There is a beep. So on this, I get a beep on the red. I don't get a beep on the green. What I'm going to do next is I'm going to take the magnet and I'm going to put the magnet on it. If the red was what was beeping and I bring the magnet, the red should stop beeping and probably the green should start beeping because the magnet is being brought closer. So let's look at this. So it's beeping now. Take the magnet, put it on. Look at it, it stopped beeping. Now let's go to the green and see if the green is going to beep. Yes, so now the green is beeping. So this just goes to tell me that the black terminal is the common. Take the magnet away. This is what is beeping. So without the magnet, that is where you have to determine which one is your normally open and your normally closed. So there is no magnet there. The red one is beeping. The green one is not beeping. So in this state, the red is the normally closed. The green is your normally open. So that's how you're able to identify it. So now I know that my black is the common, the red is the normally open, and the green is the red is the normally closed, the green is the normally open. That is just how I tested for this one. In the same fashion, when I take this one here, they're both identical. So let's see. For me to do this again, I don't have to bring a magnet close by. Just going to take that and I'm going to attach the two. This and that. Nothing is happening. So the next thing is I want to bring a magnet closer to this. So I can bring this magnet closer to it. So I brought the magnet closer, it's beeping. Take the magnet away, the beep stops. Beeps, goes away. So again, this in its default state, this is the open switch. This is an open electromagnetic switch. That's just how you test for these types of switches. On this one, this is a double pole, double throw. I'm going to test it out the exact same way that I tested this. And because the colors are identical, if I'm able to determine which of them is the common and which is the normally open, it's going to be the same for both. So if I find out that the black is the common on this one, then the black on the left is also going to be the common. And that's just pretty much how it happens. You go through the same process. Are we good with this? Any questions so far? Perfect. Just give me a thumbs up to see if you guys are understanding what I'm teaching, because it makes more sense to make sure that you guys understand what we're doing. So just give a thumbs up and let's see. The next thing we're going to do is, now that we understand all these, I'm going to go back to the board and we're going to see how we can use all these switches that we've spoken about just to draw a very basic circuit. Okay? Questions? Thumbs up?
Yeah, a lot of thumbs up.
Lots of thumbs up. Okay, so let's go to the board and try and see how we can apply all these to what we've done. So when it comes to electronics, you have to understand what input devices are and what output devices are. So an input device is going to send a signal to a control device, and that control device is going to determine whether to send a signal to the output or not. How many guys do we have on?
125.
Okay, so 125 active watches. That's good. Some of them are late to class. You guys don't be late for class, right? Don't be late for class. So an input device could be any of these things that we spoke about yesterday, from a mechanical switch to a door input, etc., etc. There is another thing that I want to talk about, which is an input device, and those ones are active devices. So let's take a look at, are you using this one?
You can take it.
No, there's another one. No, there's another one here. I'm going to take that and open it up. Yesterday we got 2 of them. Which of them? Oh, it's
Yeah, it's like, but when I took the wires out, it'll still not open it. But when I took the wires out, so if I do this, see it.
Okay.
Works, but it's just that I tried it, like I put it together right away.
no, so now it's closing.
Oh, because I pressed this.
Yeah.
So if I do this right now,
So probably that's the open circuit connected
that's
in the
open,
closed.
yeah. So if I do it like this, so let's see. It's not working. It works, right?
Mm-hmm.
It's just the button is not given.
Okay, we'll take a look at that in a second. So this is a brand new switch that I just took. Well, most of us have seen this type of switch before. This is an accessible switch. So you can have this on your wall, and someone who is on a wheelchair or someone who has a cane, they can just push here to open. Like, these are just the exact same switches that we were looking at yesterday. This is also a mechanical switch, but because you have to mechanically push it. When you look on the back, all that you have here based on the manufacturer is a Form C switch. You have the common, you have a normally open, and when I take this pigtail out, for those who can see, let's see if they can see it. You see there are 2 terminals here, one here and one underneath it. Can you see it?
Yeah.
Yeah, so there's one here and there's one underneath it. It just means that one is a normally open and one is a normally closed, depending on what design you want to use for. So pretty much most input devices are going to follow a Form A, Form B, or Form C. Any switch is going to follow one of these. Now let's go and I'll talk about switches that are active devices, right? These ones are all passive devices that I was showing you because they don't require power. Let me grab one and I'll be back in a second. Sorry, did I scare you? Try it. Yes.
Sorry, I just wanted to ask if I'm supposed to CC admin on the one to career foundations.
Yeah, CC him.
CC
Yeah, CC him.
And then do I CC career foundations on the one that I'm sending?
No.
Okay.
No, that's internal. I think it's in the bin. Where's the bin? Okay, we have the bin here. Yeah, just grab that for me. Thank you, sir. All right, so I got some here in the bin. No, this is the wrong bin. There should be another bin. Is that the one there? I'm just looking for one of those bins that has the sensors in them.
Is it this control?
Yes. Let's see, yeah. I think it's this bin here. Okay, perfect. So let's take a close look at these two devices here. These devices are input devices that are known to be active devices. When I talk about an active device, for this to work, it needs power. I need to be able to put power in to energize this before the touch sensitive portion is going to work. This is a wave active device. For me to be able to activate the wave, I need to make sure that I provide power and the power is going to keep it running. It's just like before you can turn on your radios in the car, you have to turn on your ignition. And that ignition is going to provide power to circulate around your car, and you can turn on things like your CD player, your radio, etc. So that's just what's going to happen here. Without turning on your engine, most of the cars you cannot turn on your radio. You have to put it on at least accessories. So that's what's going to happen here. For us to be able to wave on this, we need to provide power to that. So on most active devices, you're always going to find that it comes with 5 different wires, right? And these 5 different wires, you have to pull up the data sheet for these. In the world of electronics, you don't want to assume anything because we're dealing with live electricity. You don't want to assume anything. So before I start working on this, I have to look for the manufacturer. I go on Google and I type that and pull up the information that we call the data sheet. The data sheet is going to give us so many information. Just for example, here, when I go on here, and I pull up the data sheet for, let's say, this device here. I already have it. So that is this. So let's say I was working with this device, for example. This is an ELK. What was the part number again? 924. That 924 is going to tell me everything about that device. So this is a double pole, double throw relay with a trigger function on it. Before I start working with this, very important, find the product number, the model, go on Google, go on their website and pull it up. So all that the data sheet is going to tell me is how much current this is going to draw for the trigger. It's going to tell me what voltage I have to put on the positive and negative trigger. It's also going to tell me so many things, and I get that from the data sheet. So by clicking on the data sheet, I'm able to download it and open it up. So that's what you do for any electronic component. So this is the one here. To the zoom function, I'm not sure why. Okay, it's not working. But definitely when I go here, I'm able to see the operating voltage says it's 12 or 24 volts. These are some of the things that are very critical for me to know. This, the operating voltage. I definitely need to know how much voltage I'm going to put on my positive and negative terminals, for example. It tells me what my current draw is on both relays, 60 milliamps. Why is this number important? This number is important because when I'm providing a power supply, I need to know how much this is going to draw when it's working. So in the data sheet, it tells me. Also on these, we have the form C relay. This could be a common, normally open, normally closed. It will tell me in the spec sheet. The form C relay that we spoke about, it's going to tell me what the maximum amount of current I can run through this. And the maximum amount is 7 amps, rated at 30 volts direct current. Or I can do 10 amps at 125 volts AC on these relays here. It gives you the size and it tells you what the trigger voltage could be. Sorry? Huh? Oh, where's Nathan?
He's here.
Nathan? How you doing?
I didn't know you were online.
Come and say hi to the online community. Come on. Put this away. Come and say there are some Ugandans here. There are some Ugandans here. So, hey, here's Nathan. Say hello to all these Ugandans and say something to them in Ugandan. What language do you speak in?
In Uganda?
Yes.
Luganda.
Luganda.
Yeah.
Okay, let's say hi in Luganda.
What do I say?
Just say anything to them.
Okay.
Say anything to them.
Mujye bareko bana Uganda bannange.
All the Ugandans, thumbs up, eh?
Yeah.
I want to see it.
Leero ndi wano ku Delmi. Nze kulaba ku munnange Roland. Nzize kumubuuzaako era kubanga ye untraining bye twogerako wano eno buli lunaku. So yeah, thumbs up to my Ugandan fellows.
So Nathan's video, we posted one of Nathan's videos. It went viral on because he's got a lot of fans. Nathan was a student here. He came in. He was sitting there. They took the course, and Nathan has a job. He's been successfully employed. I said that, so people are going to start asking you for money, eh?
Oh, but guys out there, Delmi is a good institute. You should come and get to touch and have training from Delmi Training Institute. And Roland, you're seeing here, is a good guy, good person. To me, I'm young. He's like my dad. So I'm thankful to Roland.
Do I look that old?
But yeah, everything is okay. It's good from Delmi. Thumbs up. Thank you, guys.
Okay, Nathan.
Yeah.
So yeah, you guys heard it from Nathan. Big ups to Nathan. He's once you're a Delmi family, always. Our doors are always open. So anytime he's in the area, he just pops in, come and say hello to the family and see how we're also doing here. So today, like I said, we're dedicating this time for all of you who are not able to be here with us in class. But again, you guys want to learn something. So definitely Nathan stopped in. I want him to be a part of this. Thank you very much. You're not in a hurry, right? You got to go to work?
I am in a hurry.
Okay. All right. So, you know.
I didn't know that you were alive.
Yeah. It's fine. I said you guys can always walk in and it really doesn't matter. So thank you. Definitely after the class, I'll call you.
Yeah, okay.
Yeah.
That works.
Everything is good?
These are the
Yeah.
two comments they got from, I think these are Ugandan language.
Oh, they said Ugandan language, eh?
Habari yako.
Yeah, I understand this one.
Habari yako?
Yeah. This one is Swahili.
Oh, that's Swahili.
Yeah.
Okay.
This is the second one.
You see, they're showing love, eh?
Yeah.
That's good. That's good.
Yeah.
All right.
That's good.
So I'll call you once I'm done.
Yeah.
Thank you very much for
Thank you so
stopping
much,
by.
Alan.
Okay.
Yeah.
All right.
grateful.
Say hi to the people back at AIM, eh?
Yeah.
Okay.
Of course.
All right.
All right. Bye-bye.
Okay, bye-bye.
I have also returned the other thing.
Okay. Yeah, yeah.
Oh.
Yes, that's fine. Just leave it there.
Yeah.
Yeah.
Do you want me to go through that?
No.
Right?
No, you don't have to.
Should I put them on the back?
Oh, you can just leave them there. Yeah. Thank you very much
All right.
for bringing them.
All right.
Perfect.
See you.
Okay. Thank you, Nathan.
Thank you.
Okay, so that was Nathan for you. So the data sheet is very important to show you all that. Now, this is also very important, the trigger voltage. The voltage I'm supposed to apply on the trigger portion of this, it's going to tell me. I can use anything from 5 volts DC all the way to 24 volts. So in this way, I know not to apply 30 volts to it because it's going to destroy it outright. But I know I can apply as little as 5 volts, and I'm able to trigger this. And then finally, how much current is going to be drawn through the trigger terminal. It's a 1.2 milliamps at 12 volts DC. That's the trigger current. So the data sheet is so important when you're doing things like that. All right, so when I pull up an active device like this, what I'm looking for is the 5 wires that are going to be behind it. So this is the touch sensitive thing, touch. Behind it, there are going to be 5 wires coming out. And the data sheet is going to tell me what it is. So most of the times you would see like a red. So let me go back and do this. You would see a red wire coming out. You see a green wire. That's what I'm looking at here. We don't have blue, but we have black. We have a yellow. And we have the white. So these are the wires that are coming in from here. But because I've used this product before, and sometimes the manufacturer is so good that on the back here, they would put a bit of information there for you to see what all these colored wires represents. On this one, the red is going to be plus 12 to 24 volts DC. That's the red. The black is going to be the ground, GND. The yellow is the common. The white is the normally closed. And definitely the green is the normally open. So now that I know that these are the feature sets of that, for this touch button to start working, I need to be able to provide voltage across these 2 terminals. Anything from 12 volts all the way to 24 volts. Once I connect the power to it, then this becomes active. From yesterday's lessons and today's lessons, we learned this. Normally closed, common, and this is normally open. So in these 3 terminals, this is what I see. Look at the common. There's a direct connection between the common and the normally closed. So when I look at this, there is a connection between the common and the normally closed. So this is inside like this. So these 2 are always touching. Just like from here, they're touching. That is what happens here. So if this thing is turned on, anytime I touch like that, once I touch and I keep my finger on, because this is momentary, right? When I touch and I keep my finger on, what I am doing is I am forcing this pole to touch this throw. So that's what is going to happen. So long as I keep my finger on like that, this is going to switch like this. No, not that. This is common, yes. So this is going to switch like this. So long as I keep my finger on the touch. Now the voltage, whatever voltage I introduce here is going to come out from here. Once I take my hands off, this is going to come back like that. And so for you to have an active device work, you have to be able to provide power to it before. Where's the second active device that I had? Just before Nathan came in. Left it somewhere. That was the wave one.
The wave sensor.
Yeah, oh, it's here. So the same thing happens with this. When I look behind it, I got that same one. This one behaves the exact same thing. So for this one, I have to make sure I provide positive and negative power, and this is going to get energized. When I bring my hands close by, then it's going to trigger it. So this is an infrared sensor. So these are the different types of input devices that we have. So let's try and draw some circuits now. Anytime we have a switch, which is an input device, we need to connect it to either a control center or a controlling device. And this could be a relay, access control panel, fire panel, anything like that. And then we're going to have an output here. So this is going to be the control device. This is pretty much most of the time the decision maker. And this is what is going to demonstrate the output. So what are some of the output devices? An output device is just going to take power, voltage, and consume that voltage and convert that energy from one state to another. So some of the things that could be output devices are, for example, a door strike, a magnetic lock, Maglock, a fan. I'm going to leave it to you guys. I want each and every one of you to try and name one output device. I've given you 3. So a door strike, a Maglock, a fan. I'm going to give you 4. Let's say an LED light. It's an output device. So I'm going to wait for 1 minute. I want you guys to tell me what you think an output device is.
Drop lock.
A drop lock. So that's one. So I said
Buzzer.
a buzzer is one.
Somebody said TV.
TV is an output device, yeah. So you just have to, you can do something and the image is going to appear on the screen. So it's considered an output device. So TV,
Strobe.
a strobe,
Motor.
a motor,
Speaker.
speaker,
Sliding automatic door.
yes. So, I mean, now you guys got it. These are all output devices, right? And the list goes on and on and on. So when I have an input device, when I wave, it goes to that control device, and the control device will determine what the output will do. So if it's a fan, and I want the fan to spin when I go to the input device, then there is a way I have to wire it to have that fan spin. Okay, so these are some of the things we're going to look at. But we're going to try and draw a very basic signal. So first of all, I'm going to do one using a switch. Okay. We're going to use a single pole, single through switch. So what I always want to do is, I'll take the switch, and I'm just going to draw my switch like this. Off. And because it's a single pole, single throw, I'm going to use one that is in the open state. So this is going to be the common. This is going to be the normally open. So this is what it is. And I want, when I toggle this switch, I want it to turn on a fan. So this is my output device. What I want to determine is this fan. For me to be able to operate this fan, how much voltage do I need for this fan to work, right? That is very important. How much and what voltage and what current is needed. So if the fan is a 12 volt fan, then I have to make sure that I have 12 volts flowing through the circuit. So let's say this is a 12 volts DC fan. Then definitely what I can do in basic terms is I need a power supply that is going to be 12 volts DC. So what I'm going to do is I find a 12 volts power supply, and this is positive and negative, right? With the output device, anytime you see an output device, you're going to have two terminals. You're going to have a positive and a negative. So how do I connect this? I want this positive voltage to go through this circuit and come back home. That's just what I want to do. So this is the very basic, the most basic way that we can do it. I take this positive. There are two ways you can do it. Remember, this is just a switch like this. That's how it looks like. Common, normally open. So there's a break. That is what this thing represents. When I press this button like this, it's going to force this to touch that. And then when I push it back up, it's going to break it. That's just pretty much what it is. You guys are back? Okay, Jama, come and say hello. So, you know how we're doing it today? I have Jama, and Jama is...
Hello, sir. How are you?
I'm good. How are you?
I'm good.
So we're live. We're on TikTok, and I want you to say hi to the online community. So some of them might know you.
All right. Hello, guys. This is Jama. I was previously student in Delmi Institute. Now I'm doing my internship, which is a co-op. So, and I'm learning so many things, step by step. So I'm giving, recommendation for the people who are watching me. No matter what you study here, field, is totally different. You have to have a co-op. Yeah. So that's my recommendation. And nothing, you have to learn everything from the scratch. So, and make implementation in the field. So I would like to give, big thanks to our boss. He teach me so many things.
Yeah.
So,
but you're still learning a lot on the field, right?
Of course, yeah, of course, yeah. I'm still a student here.
Yeah, still, always, yeah.
Yeah.
Okay.
Yeah.
Thank you very much.
Yeah,
So
welcome,
Jama, welcome. So Jama is just coming back from the field, and he tried to get his hands dirty. And who else do we have? Oh, Senna, come here. Senna, come and say hello. Come and say hello. So Senna was also, I know most of you have been watching her videos, so, and Jama's videos as well. So Senna also came, and I think she went around. Oh yeah, there you go. So yes, we have a lady in the house, and Senna was also a student, same with Jama, so she's just coming back from the field. And say hi to your Ethiopian friends.
Okay.
Yes.
Hi, my name is Tina.
You know, anytime you come here, I like you to speak Amharic.
Oh, okay.
Yes. Okay, so
ሰላም እንዴት ናችሁ? ዛሬ ፊልድ ወተን ነበረ እና ኔትወርክ እና ካሜራ ለመስራት እና ለማየት ሞክረን መጣ።
What did she say? I hope she didn't say, she said all good stuff, right? All the Ethiopian brothers, they help a brother out. Let me know what she said. What did she say?
All good stuff.
All good stuff. Okay, you see, all good stuff, right? All right. Oh. Paji. Okay. So thank you very much, guys. Yes, thank you very much. All right, so let's continue. So like I said, this is the most basic form. What we're trying to do is this is just a switch. It breaks or makes the circuit. So it really doesn't matter where I'm going to take my positive voltage. I can decide to bring the positive voltage from here and connect to the normally open. And now that voltage, because this is in the off state, what the switch looks like is like this at this point. So that voltage, if I fed the voltage in from here, 12 volts DC, that voltage is going to stay here. So this one here is going to stay here. And it's not going to go anywhere until I close this switch. Once I close this switch by pressing this, this is going to touch like this. And the moment it touches, the voltage is going to flow through here and come out from here. Right? So I can take this one here and connect it to the positive. Right? And I connect it to the positive. So now what I'm having is the 12 volts DC is going to come from here, go through the switch depending on whatever the state is, and come all the way here. Now I have sent 12 volts with a specific current draw. Remember, energy cannot be what is it? Energy cannot be created nor destroyed. However, you can change the form from one state to another. So once we bring the electrical energy here, it's going to change into the fan energy. So the fan is going to be spinning. Once that energy is consumed, it has to connect to where it started from. So once that energy has been consumed, I have to make sure that my circuit is complete by taking the negative from here and connecting it here. This is the most basic form. So when I turn this on, it would depend on the type of switch, again, that I'm using here. If it's a momentary, you guys are going to tell me what is going to happen. And if this is a maintained, what is going to happen? So I want you guys to tell me, if this were to be a momentary switch, and I press this, and I took my fingers off, what was going to happen? I just did one press and took my finger on. We're dealing with momentary. What do you guys think was going to happen to the fan?
Somebody said momentary blink.
Momentary blink, right? And that's correct. Because once I press it, it's going to close the circuit and just allow electricity to flow through briefly. And this is going to start spinning. Once I take my finger off, the fan stops spinning. What if it was a maintained switch? When I press the button, what do you guys think is going to happen?
Maintained constant.
Maintained and constant. So this fan is going to continuously spin until I toggle this. All right? But this is just a very basic form. That's how you connect it. What if now I wanted to connect two devices, and I wanted these devices to behave differently? At that point, I need to introduce something, a control device, that is going to let these two devices behave differently. And this takes us to our next scenario. So at this point, let's say I had a red LED. I'm going to draw that with a red. You know, a red LED, which is an output device. Red LED. It works at 12 volts DC. And I have another one, which is a green LED. Right, green LED, this also works at a 12 volts DC. All right, And I have the same switch here that we were looking at. Off. Common, normally open. So now this is what I have. I have these two devices, but I want them to behave separately. What I want to happen is when the device is in the off state, right? Off state, I want this red LED to be on. And then when I turn this on, I want this red LED to go off and the green should turn on. Right? That's just what I want to do. So when someone is approaching and they see a red, they know that the door is locked. When they see a green, the door is unlocked and they can go in. This is a very simple circuit. Now, because I have two devices that I want to behave separately, what I need to do is I need to introduce a switch or a relay. Okay? And this that I'm going to introduce here, I'm going to introduce a single pole double throw switch.
Can you pass me a flathead?
A flathead?
Yeah. No, it's not. It's Robertson.
That's Robertson?
Yeah. Oh, okay, a bigger one.
A bigger Robertson? Okay, guys.
That red one there? The red hand?
Oh, this one?
Yeah.
Robertson? Is it a big Robertson?
It's a big, yeah.
Okay, you can try these two. Right, so what I'm going to do is I am going to introduce a switch that is a common, normally open, normally closed. Right, that's all I'm going to introduce. This is going to be my control device, and at that moment, I'm going to connect it to these two things here. So let's see how we're able to wire it so that these are able to work the same way. First of all, you got to determine the voltage. You guys got to determine the voltages that these two devices are going to be consuming. And based on that, you're going to determine the power supply that you have to use. Remember, the only two things that need power is these two, and they're both working on 12 volts. So it's going to be very simple. I'm going to look for a 12 volt power supply, and I'm going to put that here. 12 volts DC. This is going to be the positive, that's the negative. All right? So what I'm going to do is, I'm going to take I have to introduce the positive and the negative here. So with this relay, because it's an active relay, you need a positive and negative, and this is just going to energize this board, right? This is the coil side, which I'm going to talk about, and this is the relay portion. So what I'm going to do is, I'm going to take this positive from here like we did before, and connect it to the common. And I'm going to take the output from here, and I'm going to connect it to this positive. The next thing is I'm going to take the negative from here, and I'm going to connect it here. This is an active circuit, so I have to turn on the relay portion. Having done that, let's look at this. The scenario that I was talking about is, I need this to be on all the time, even when this switch is off. And when I turn it on, I need this light to go off, and this one should come on. So let's see how the electricity goes. But before we can understand that logic, let's go back to the switch that I had drawn. You have this. This is normally open, this is normally closed, and this is common. So look at this. if I introduced any voltage here, 12 volts DC, where do you think I'm going to see this 12 volts? Am I going to see it here, or I'm going to see it here? I need you guys to tell me. Is it going to appear at the normally closed or at the normally open?
Normally open.
Normally open?
A lot of answers normally open.
Normally open. So look at this, just in its default state. This is normally open, this is normally closed. If I brought 12 volts here, look at this one. This is connected to normally closed and not normally open. So this voltage that I'm introducing here, I'm going to see it at normally closed. Because when you look at the relay inside it, this is connected like that. That is what is happening inside between the common and the normally closed, like this. So when I take 12 volts DC from here, like this, and I bring it to this common, guess what? This is how it is. So that voltage is going to be here. And as a result, if I do connect the positive of my red LED to the normally closed, that electricity that just came here, remember this is still off, so there's no voltage coming here. But I introduced 12 volts to this common. That 12 volts get transferred to the normally closed, continues to come out from the normally closed to the positive of the red terminal. And if I continue to connect this like that, all the way back to the negative, then my circuit is complete. Look, I don't even have to worry about this. Positive voltage comes from here, goes to the common. You guys, can you keep it down a little bit there? Comes from here, it goes to the normally closed, comes out from the normally closed, goes to the positive of the red LED. This turns on because the circuit is complete. Now let's look at what is going to happen. Because I want this one to always remain off, when this switch is off, then there is no voltage coming through here. So what I can do is, I can connect from here, this, to the positive of this terminal, and I'm going to connect that from here all the way back to this negative. So let's look at what happens. On this relay, I'm going to explain how a relay works, but you guys understand this first. Now that this is in the off position, this relay is not energized. So because it's not energized, this is the flow of voltage. Comes from here, goes all the way. This gets turned on, and then it comes back home. Now, the moment I turn this on, this is a maintain switch. I push this down, it's going to stay. Now, what is going to happen? That 12 volts is going to come here, go out from here, it's going to come here. The moment I activate this position of the coil, now it's going to force the connection that goes between common and normally closed to now come to common and normally open. So that voltage that was here is now here. So what is going to happen to the red light? It's going to go off. And this voltage that came from here is going to flow through the green. It gets consumed, and it comes back to the ground. Okay, so this is what we are trying to achieve. Having understood this, I'm now going to go in and talk about what an electromechanical relay is. So an electromechanical relay, from all that we were looking at, we looked at a mechanical switch, we looked at an electromagnetic switch, but what is an electromechanical switch, which is a relay? It is a switch that is controlled using electricity. So this is how it works. On an electromechanical switch, or relay, you could also get them in the single pole, double throw, and the double pole, double throw. You can get them in this, and I'm going to explain. A relay has two portions to it. It's got the coil side, and it's got a relay. How this works is, you are going to use a small amount of voltage to energize the coil, and it's going to allow you to switch a bigger amount of voltage on the relay terminals. Let's look deep into how that works. They use the principle of electromagnetic induction to do this. On the relay side, on the coil side, we have this. We have a soft ion, and they have a lot of coils around it, like that. This is what happens. For those of you who don't know, I'll talk a little bit about physics. If we have a straight wire like this, just a straight wire, and I start to send electrons on this wire, it creates what we call...
Call me after probably for that, please.
Okay.
It's simple though.
It's very simple.
It was only 8 strikes, 8 readers, and then the 4 panels. They didn't have door contacts, no request to exit.
Okay. We'll talk about that tomorrow.
Okay.
Okay. Okay. So if we have a straight wire and we have to send electricity to it, there's going to be an electromagnetic field that is created. So around this, there's going to be an electromagnetic field around this wire. But when we coil it around a soft ion, we get what we call a temporal magnet. Not a permanent magnet, but it's going to be temporal. Okay, so tomorrow, right? I'll call you. So when you send electricity through it, the soft ion that is in becomes magnetized. And when you take the electricity away, it becomes a soft ion. That's just how they've done it. So let me go back and draw our single pole double throw. We have this. This is the common, this is the normally closed, this is the normally open. All right, so we have this. And this is the relay portion. And this is the coil portion. This is the relay, and this is the coil. Now let's look at what is happening. Remember I told you that if I have a soft ion and I run a coil around it and I send electricity through it, this becomes a temporal magnet. And this, it's able to switch the pole between the two throws. So this is one terminal here, and this is another terminal. So this is how it is. But what they've done is they've connected a rod to this arm that is here. Remember how yesterday I was saying that if we have a rail and one turns like this and the other, there's a guy who stands there and he pulls the bar and switches the rail to come here so that the train can go here. And if the train has to go that way, they have to push it back to allow the train to go. So let's think about this as that miniature man who is standing inside that, pulling to switch the direction of the train to either go here or to either go here. At every point in time, the train can only go one way. And the default way that the train is always going to go is, let's say, is the normally closed terminal. So what is going to happen here? Let's say we have 30 volts DC connected at the coil here. And we have a light. I have a red LED light here. And I want this light to only turn on when this comes here. And this is 30 volts DC. This is the plus. So let me take this one and I'll connect it to this normally open here. For example, I have a plus, 30 volts DC. This is my plus and this is my minus. I'm going to take this positive and I'm going to connect it here. So that positive voltage is sitting here. But directly we know that once I connect the 30 volts here, I'm going to see 30 volts here. It can continue to sit there. Nothing is connected here. What I did was I connected a red LED to this terminal here. So all that I can do is to take the negative from here and connect it to the negative of that red LED. So let's look at what happens. I need this electricity to flow through here. So what we're going to do is probably this coil here only accepts 5 volts DC. Just have to look at who manufactures that relay. So let's say this coil knows only 5 volts to become magnetized. So this is going to be the positive, this is going to be the negative. All I have to do is to find a 5 volt power supply. Negative, positive. All I'm going to do is to take the positive from here. Let me use a red one. Take the positive from here and connect it here. And I'll take the negative from here and I connect it here. But look at this. The moment I connect it like this, this becomes magnetized. And it's going to stay like that for a long time. So what I really want to do is I'd want to put a switch in here so that I can make or break that. I'm going to put a switch here. So I put a switch. So anytime I close this switch, now that 5 volts is going to flow through here, go through this coil and come back. The moment electricity flows through this soft ion, the soft ion becomes magnetized. This becomes magnetized, and this is another piece of metal. What is going to happen? It's going to attract that metal towards itself. This is going to move here. And once this moves, it's going to move the arm from here to here. And then that electricity starts to flow through here. And when I open this circuit here, when I break this circuit, meaning that now no electricity is flowing, this is no longer a magnet. So it's going to let go of this. This is going to go back. And this comes back and makes contact here. And then the electricity will continue to flow through here. When I close this switch again, electricity is going to flow through this coil. This becomes magnetized, attracts this guy to itself, and this pole is going to move here. And that electricity that I brought in here is going to start going from here, going to the LED. The LED is going to turn on and come all the way back to the power source. That's just pretty much what it is. Do we understand this portion before I move on? So if you understand, let me see a thumbs up. If you need questions, you need some clarity on this, ask your questions before we move on to the next portion.
Yeah, a lot of thumbs up.
A lot of thumbs up, right?
We have active 374 people watching.
374. Okay. So good. Now that we understand the relay, let's go back and look at this. This is very valuable based on what we're doing. So let's look at the different types of relays. This is just a regular relay. It's got a positive and it's got a negative. And we can have one that has a normally open, common, and normally closed. We can have another relay like this. That has a positive and a negative. Remember, the positive and the negative here, they are different. This is the coil portion, like I spoke about. And we can have another one here, like this, normally open, common, normally closed. And we can have another terminal here, normally open, common, normally closed. And we can have another type of relay here. Let's look at that. It's got a positive, it's got a negative. It's got these here, and normally open, common, normally closed. And it's got this, and normally open, common, and normally closed. What we do have here, though, is we could have another terminal. This coil is separate, but we could have a trigger plus and a trigger minus. Let's look at what these different relays are. This, who can tell me the name of this? It's a single pole, what? Do we have any answers yet? This relay, let's look at it.
Double throw.
Double throw?
Somebody said single throw.
So,
Single pole, double throw.
yes.
Single pole, double throw.
Single pole, double throw. So majority is single pole. So those who were here yesterday, they understand it. We have one pole. When we look at it, this is how it looks like. Normally open, normally closed, common. So we have one pole and this pole. This pole switches between these two throws. So these are two throws here, and we have one pole. So this pole can either move here or move here. So it's just a single pole that is moving between two throws. So we call this the same thing here. We have a common, which is here. We have the normally closed, which is here. We have the normally open, which is here. So this that we're looking at here means this. And that is a single pole double throw. That's just what it is. Now let's look at this. This is, who can tell me the name of this relay here? And as you do, prepare for that one as well. Can you tell me what this one is? Maybe when I draw the schematics, you guys are going to understand it better.
Double throw. Double pole, double throw. Double pole, double throw. A lot of them said double pole, double throw.
There you go. So it's a double pole, double throw. And it's a double pole, double throw because we have how many poles? 2 poles. But this pole here is only common to this one. And this pole is only common to this. So as a result, we have 2 poles, which is double pole, and we have 2 throws, which is double throw. So this is the same as this, double pole, double throw. We're going to look at what the differences are with these ones. This is a very simple one because if you have a device that you want to connect and let them act differently, you can use this. So, but if you have a device or multiple devices that works using different voltages, right? Different output devices that works using different voltages, then you need a double pole, double throw, because this here becomes 1 circuit, this becomes 1 circuit, and this becomes another circuit. What it means is that I can introduce, let's say 24 volts at this common. That 24 volts is going to come here and come out. And I can decide to introduce here 15 volts. That 15 volts is going to come out from here. That's how it works. So I'm using 2 separate circuits. So let's say I had a fan that was working at 24 volts. This is a 24 volts DC fan. And I had a door strike, for example. Door strike that was working at 15 volts. I can connect my door strike here, and I can connect my 24 volts fan here. So anytime I energize this coil, what was going to happen was 24 volts is going to flow through my fan, 15 volts is going to flow through my door strike. So by using two separate voltages, I'd need a double pole, double throw. It's the same thing like this, but this one works a little bit differently. You know, with this, I need to energize the coil here. I need to send a positive and a negative here. When I send a positive and a negative, then it's going to switch between this to this, and this is going to move here. And when I take the power away, it's going to go back. This is going to, at the same time. Think about it, like the two wiper blades. They sit in here. When you press the wiper, they both move together. And when you cancel it, they come back, right? So think about it like that. The action happens the same. So when I toggle this, the difference, whatever is going to happen between these two, is going to be exactly at the same time. So if this is connected to this, and this is connected to this, the moment I apply power, they're both going to move here at the same time. So whatever I connect here and whatever I connect here, they're going to trigger at the same time. If I wanted my fan to always be spinning, then I have to connect it to the normally closed, because the normally closed is always connected to the common. And if I wanted my fan, my strike, not to be unlocked, then I'm going to connect it to the normally open because there's no electricity there. So this is going to stay locked. This is just to let you understand. Now let's look at how we are going to connect this one. This one is a little bit unique because it's got a positive and a negative here, positive and a negative. Oh. It's got a positive and it's got a negative here. But at the same time, it's got a trigger positive and it's got a trigger negative. So let's look at how these ones work. So let's say the guy watching me from Uganda. What's the Uganda guy's name? The Ugandan guy and the Gambia guy. I know the Gambia guy is called Fode. Hello, Fode. If you're watching, give me a thumbs up. So, Charles. So we have the Ugandan guy, Charles, and we have the Gambian guy, Fode. They're supposed to be racing, and they're going to be racing in the exact same cars. So they both have car number 1. This is the racetrack, right? This is Gambia. And this is Uganda. So this is the Uganda guy here. They all have the exact same specifications of vehicles. So let's say a C-Class, AMG. C-Class, AMG. Same spec, same factory, everything. And this is going to be the finish line. That's where they're both going to go. But then they're going to tell the guy from Gambia, who is 40, they're going to tell 40, turn off your engine. So engine off. But they're going to tell the guy from Uganda, who is Charles, turn your engine on. So engine on. When the referee or whoever it is says go, they're all supposed to move from here and they're supposed to go. Who do you think is going to be able to take off first? This guy's engine is off. This guy's engine is on. He's in first gear and his leg is like this on the trigger, waiting. So His engine is running, his leg is waiting for the green light. This guy's engine is off. He has to press the brakes, turn it on, switch it to first gear or to drive before even attempting to put his feet on. So definitely this guy is going to, by the time this guy finishes turning on his vehicle and doing everything, this guy is already gone. The same thing happens when we look at these two types of relays. This one, we have to send power here to turn the relay on before the switching happens. But when you look here, we've already provided power to this relay. So this relay is already energized, but it's only waiting for a trigger. As soon as it detects the trigger, right away it switches. And if you take the trigger away, it switches back, but it still has power. So this type of relay is a fast-acting relay compared to this. So when you look at the prices, this is a little bit more expensive, slightly, than this. And we're going to look at how we can wire each and every one of them. Remember, you use double pole, double throw relays if you have different voltages that you want to use, or you have multiple devices that you cannot connect here. Again, I can use this for the same voltage, 12 volts, but probably I have multiple things I want to connect. So I can utilize these ones. So let's take a single pole, double throw, and wire it up and see how it is. We're going to take a double pole, double throw, and wire it up and see how it is. And we're going to take one that has the trigger built in, and we're going to see. Once we understand these, I'm going to introduce other relays, like a relay that has got a timer in it. So when you toggle it, you are able to see. So the first one I'm going to talk about is the single pole double throw relay. We're going to use that in a second. Any questions so far? Thumbs up if everything is good. All right, so the first thing I'm going to do is I am going to grab an input device. I'm going to get the relay, and I'm going to grab an output device. So I want you guys to give me two types of output devices that you want me to use, and give me an input device that you guys want me to use. I know I'm going to use a single pole double throw relay. So plus, minus. This is a single pole, so we have this, the normally closed, normally open, and common. It really doesn't matter how I write this, so long as you understand the concept. This is a normally closed, normally open, and common. So I need two types of output devices, and tell me what the voltages are. Because I'm using, no, my bad, I'm only using one. Because I'm going to use only one of these relays, they both, whatever output devices you guys are going to tell me, they both have to operate on one voltage. Because remember, I cannot put a 12 volts in here. I cannot put a 12 volts in here and at the same time put a 24 volts. It's not going to work. You cannot put two separate voltages in here. It has to be only one voltage. And that voltage is going to be here, and then it's going to switch to here. So if it's not here, it's going to switch to here. That's what I want you guys to understand. So give me two output devices.
Motor 12 volt.
A 12 volts motor. Okay, so we have a 12 volts DC motor. Plus, minus. What else?
Somebody said input device, momentary wave sensor 12 volts.
Okay, so input is going to be a momentary wave, 12 volts DC. Good. Now I need one more output device. Come on, guys. Output devices.
Siren,
Siren.
buzzer, light.
So I got a siren. Plus, minus. So now I want you guys to tell me, how do you want this 12 volt model? So this is a 12 volts DC model. I want you guys to tell me how you want this motor to happen. Do you want this motor to always be spinning, or you don't want it to be spinning? You want that siren to be buzzing all the time, or you don't want it to buzz? If you want this siren to only buzz when I send an input, when I toggle an input, you tell me. If you want that motor to only spin when I do something here, it's up to you guys. So tell me, how do you guys want this to behave?
You spin all the time.
So spin all the time. So motor spins all the time. And what about the siren? I assume the siren is only going to make some noise when I do the wave. So siren only blurs when wave sensor. Okay, so this is only going to make noise when the wave sensor, but this is only always going to spin. When I wave on the sensor, that's when it's going to stop spinning. When I take my hands away from the wave sensor, it's going to continue to spin. Now that we understand how they are going to behave, let's see how we are going to wire that up. Based on the knowledge that we have regarding when I bring in 12 volts here, that 12 volts is going to automatically show its ugly head here, right? So with this knowledge there, this is 12 volts, that is 12 volts. I have to look for a power supply that is 12 volts. I got to go and look at the data sheet for this and pull up the data sheet for the siren that I'm using, and I have to see how much current this is going to draw, how much current that is going to draw. This is going to help me to determine the type of power supply that I need. So I'm going to get my 12 volts power supply here. 12 volts DC. This is the plus and this is the minus. So what am I going to do? Because I want this 12 volts to always be spinning, remember, when I bring this positive voltage and I bring it to the common terminal, it's going to show up here. So when I take the positive of this model and I connect it here, right away, that positive voltage is going to go to the model, and the motor is going to start spinning. I always have to make sure that I connect the negative to come back to where the battery is. But with this, I don't want it to make noise until I wave something. So what I can do here is I can take the positive from here. Anytime I'm drawing circuits, I don't like to cross the line. So anytime I have to cross the line, I have to jump it. And I bring this and I connect it here. And in the same way I take the negative from here, I can just touch this negative, is coming back. So let's look. When I'm drawing circuits, I want to look at the logic here first before I even start to interrupt it here. So let's look at this. Positive 12 volts comes from here, it gets here. This doesn't come here. This voltage comes directly here. And what is connected to it? The fan. So right away, the fan is receiving 12 volts, sorry, the motor is receiving 12 volts and it's going to start spinning. As it spins, the siren is off because the siren is connected here and nothing is going to happen. So this is the correct wiring here. Now let's look at the input device. We're talking about a wave sensor. So this is the wave sensor. And what he made me understand was the wave sensor was 12 volts DC. So there's going to be a positive and there's going to be a negative. And at the same time, there is going to be what we learned, a common, a normally open, and a normally closed. This is how the wave sensor is going to be. It's got 5 pigtails. 1, 2, 3, 4, 5. So because this is 12 volts, I'm going to get a 12 volts DC power supply. That is going to have a positive and a negative. So what I'm going to do is I'm going to take the positive from here and I'm going to connect it to the positive terminal here. And I'm going to grab the negative from here and I'm going to connect it here. Now, just by connecting this, I have just energized the internal electronics of this. So now when I wave it, you would hear the relay clicking, and I'm going to demonstrate that. At this point, because I need to bring 12 volts to this coil, I'm going to take the 12 volts from here and I'm going to bring it to the common. And what is going to happen? This 12 volts is going to show its head here because common and normally closed are together. So if I connect this to that, right away this is going to be energized. And when I wave, it's going to take the voltage. So if I walk away and I connected it to the normally closed, this is going to constantly receive power. And that's not what I want. So I'm going to use the normally open because this electricity is already coming out from here. There's nothing coming out from here. So it makes sense for me to connect this to the positive here. But I have the negative coil here. I have to make sure that that electricity is complete. So I'm going to take this, jump it, and connect it here. So now let's look at how this behaves. This is already on. When I wave, it's going to take that electricity that is sitting here and bring it here. So I wave and I keep my hands there. Now the electricity flows through here. It comes here. Now I have 12 volts DC here because I'm still waving on it. This relay coil is now energized. So I've told the man to pull that trigger here. So that arm, he's pulled it away. And now that electricity that I put in here on the common that was showing up at normally closed, it's now going to show up on normally open. And if that shows up here, what is going to happen to this motor? I've taken the power away from the motor. The motor is going to stop spinning, but I've brought that 12 volts to the siren. So by keeping my hands in here, now the electricity is coming from here like this, and it's no longer here. It's no longer here. The 12 volts that I brought, it's now here because I'm still waving. So that electricity goes from here to the siren. And my siren is going to be blaring until I take my hands off. If I take my hands off, now this comes back to the normally closed. This doesn't receive power anymore. And the voltage is taken away from here and is brought here. That is just what is going to happen. And at that time, the siren is going to stop and the motor is going to start spinning. Are we clear? So now I'm going to give you guys an assignment. And I want each and every one of you to do a quick. I'll just give you like 5 minutes. And you guys just draw it on a piece of paper. Take a picture of it. And let me see what you guys have done. The assignment that I'm going to give you guys, I want to make sure that you guys understand. We are going to use as the input device I want you to use a door sensor, which is one of these. right? It's a magnetic switch. You can even hear it, right? When I bring it, you can hear the switch going on. Let's take a look. I'm going to bring it closer to the mic. You guys can hear it, right? That's just what is happening. So you're going to use this. It's going to be a single pole, double through magnetic switch. That is going to be your input. We are going to use a relay plus minus. This is going to be a double pole, double throw. We're going to have the normally closed, common, and normally open. And here we're going to have the same thing, normally closed, common, and normally open. But what I want to do here is this time. This is a Maglock. Plus minus, and this Maglock is 12 volts DC. And I have a door strike. The door strike is the fail secured. Door strike. It's 12 volts, 24 volts. Fail secure just means I grab a door strike. A fail secure door strike means with no power connected to it, the strike is locked. When I apply power, this unlocks. That's just all it means. We're going to go in depth in it. So this is a fail secure door strike. But also what I want to have is a 12 volts red LED. I'm going to put that here. Red LED. 12 volts. It's got a positive and a negative. And I'm going to have next to this one a green LED. And it's going to have a plus and a minus. Now I'll tell you what's going to happen here. Plus, minus. What I want to happen is, this is 12 volts, this is the green, it's also 24 volts. I want the Maglock to always be locked. When the Maglock is energized, I want the red LED to be on. And when the door strike is unlocked, which means that this should also be unlocked. When this is unlocked and this is unlocked, then the green LED should turn on. How does a Maglock work? The Maglock works exactly the same as what I was telling you happens on the coil. So inside the magnetic lock, it has a piece of metal like this. And that has a coil built around it, like that. And that coil comes back here. So when you send electricity around the soft ion, it creates a temporal magnet. And when you bring the plate next to it, it attracts it. When you take away the electricity, it's no longer a magnet. So this is just the principle under which a magnetic lock works. Right? So now that we understand it, we know that this Maglock, for it to remain locked, it always needs power. So you're going to determine which one always needs power. At this point, you're going to need a 24 volt DC power supply. Here, 24 volts. And you're going to need a 12 volts power supply here. PS, 12 volts DC. And you're going to need a PS power supply, 24 volts. So I'm going to give you guys a few minutes to draw this. What I want to see is you are using two magnetic switches that is in the normally closed, common, and normally open. And this is a 12 volts. This trigger here and here, the coil side, is 12 volts. This coil is 12 volts. So let me see how you guys are going to draw that. This is a PS, 12 volts DC, plus, minus. Let's see how you do it. Give 5 minutes. And then once you just finish, just send a picture, or I'm going to get you guys to help me to wire this. Do you have water at the back? Barack?
Yeah.
Do you have water at the back?
Water at the back?
Yeah. Like that. 10 minutes, we should be fine. Okay. Yeah. You want water? Grab another one, Marek.
Oh, it's your...
No. He's a bunch of... Come on. You want water?
No. Yeah, I don't think they can send it.
Oh, they cannot send pictures? Okay. At least if they cannot send pictures, that's fine. So I was just informed that you guys cannot send pictures. So let's see how you can wire it. After that, you're going to compare it to what you guys were able to draw. Like I said, I always like to start from my output devices. The scenario here was the Maglock always needs power to remain locked, because I explained the principle under which a magnetic lock works. It works just the same principle under which the coil would work. So I always like to wire this first. The problem though is these devices operate on a 24 volts. These devices operate on a 12 volts. So I have to be very careful I don't mix and match my power. So it's up to you to determine which of these circuits you're going to use for your 12 volts and which one are you going to use for your 24 volts. So I'm going to decide that I'm going to use the 12 volts up here. So this here is going to be my 12 volt circuit. And whatever is here is going to be my 24 volt circuit. That's what I'm going to do. So let's look at this. This guy here needs constant power to remain logged. And as a result, when I take my 12 volts power supply, which is positive and negative, this is my 12 volts. I'm going to take the positive and I'm going to connect it here. Probably I should use the red, it makes sense. Take the positive and connect it to the common. Right away, where do you think I'm going to see it? I'm going to see that voltage show up here. And because I want this to always receive voltage to remain logged, it makes sense for me to take the positive from here and connect it here. But at the same time, because this, I want this to behave the same way like this. If this is logged, I want this light to be on. And they're working in 24 volts. It just makes sense that I can tap into this line. So this is receiving power. This is receiving power. The light turns on. The Maglock latches. What happens to these two negative terminals? They always have to come back where it started. So I sent the energy here, and the energy was consumed. It just makes sense that I complete the loop by coming back here. So I can take this negative and put them together and bring it all the way here. And that circuit is done. Now let's look at this one as well. This is 12 volts, that is 12 volts. Sorry, that is 24 volts, this is 24 volts. So I need a 24 volt power supply, and this is going to be the plus, and this is going to be the minus. So now let's look at it. Again, I'm going to take the plus from the positive from here. And I'm going to send it to the common. The way the electromechanical door strike works is this. When I send power to it, it unlocks. If there's no power, it stays locked. So if I want this to unlock, and I connect it directly here, because you know when I bring the positive here, this automatically comes here. So what is going to happen if I connect this here? Right away, this is going to get power, and this is going to stay unlocked. If I also connected the green LED here, right away the green LED is going to light up because the voltage is sitting here. But that's not what I want to happen. I want when this one unlocks, then this light turns on. Now there's no electricity here. The only time the electricity is going to come in is when this comes, or this is broken. When I break this one, then it's going to allow the electricity to flow through. So then it makes sense that I connect this here, right? And I connect the same one here. Now I'm left with the two negatives. Remember, I took the power supply from here, so it has to go back. I connect it from here, and I connect it to this, and I do the same thing, connect it there. So remember how this one is connected on the normally open, but these maglocks are connected to the normally closed with the light. So this side has been wired. Now let's come here and see. This is the coil portion. Anytime I energize this by sending voltage here, this voltage that is here will switch here, and this would also switch here. So let's see how we work this out. This is an electromagnetic switch, meaning that I'm using this as my switch to break or make the voltage that is coming out from here. I have the positive that is here. So what am I going to do? I'm going to take the positive from here, and I'm going to bring it to the common. Right away, that voltage sits here. And if I were to take this and I connected it here, automatically this relay side is going to be energized and it's going to switch it. And that's not what I want. I want to be able to be the one controlling how this relay behaves by bringing this closer and taking it away. So connecting it here, no, sorry, yes. This is normally closed. My bad. I did not look properly. So let's look at this again. Here. Yeah, this is normally closed. If I took this and I connected this here like this, this is the normally closed. Any voltage that I brought in here is going to show up here, and it's just going to come here. So this coil is always going to be energized, and this is going to be permanently locked on the normally closed, normally closed. So what is going to happen? This here is going to be unlocked. This is going to be, this here now is going to get here. So this is going to be unlocked, get power, but this is going to be here. So if this comes here, this is also going to be unlocked. So my doors are going to be unlocked all the time, and that's not what I want. So instead of doing that, instead of doing that, I want to take it from here and connect it to the positive. But I still have the negative here. I'm going to take the negative from here and I connect it here. So now let's look at what happens. The power supply sends a positive voltage. That positive is staying here. I'm going to bring the magnet, because this is an electromagnetic switch. The only thing that can switch this is the magnet. When I bring the magnet close by, it's going to allow the electricity to flow through here. When I bring the magnet close by, it's going to force the electricity to come here. Once the electricity comes here, it goes to this. Now the coil on here is energized, positive, negative. This is going to move from here to here. And this is going to move from here to here. So now look, the voltage is here at this point. Nothing is connected to it. So this red light is not getting power. So it's going to go off. This maglock is no longer getting power. So it's no longer a magnet. So the plate is going to separate. That's what's going to happen here. Now let's look here. The voltage is now here. So the 12 volts cam goes from here. Sorry, the 24 volts cam goes from here. Look what is getting power, the positive terminal here. So what is going to happen to the green LED? It's going to turn on. What is going to happen to this? Because the positive comes here again. Now this door strike is getting power. And as a result, it unlocks. Right? So that's going to unlock when I bring that close by. And that's just pretty much what is going to happen. When I take this away, all right, when I take this away, now everything is going to switch back to the way it was. So these are just a few examples that you can use. Any questions?
No, not so far.
If my explanation made sense for you guys to understand how to connect devices to a relay, I want to see thumbs up. And for those of you who are new to our channel, I want to welcome you. This is Delmi Training Institute, where we offer hands-on technical training. We break everything down for you guys to see. We're going to be back here again, same time tomorrow, and we're going to continue our series of electronics. So this week we're working on electronics. Next week we're going to be working on something else. We started with the cabling last week. We did not finish, but we're going to get back to that. But this week we're working on electronics because most of you, the comments that were, the emails and the messages that we're getting was, let's get some electronics going. So if you guys found this value, make sure that you share our videos. Send them to your friends who you think they are also going to benefit from here. We are recording this session. We're going to upload it directly to YouTube. So for those of you who were occupied as a result of work and other schedules that you could not be part of this live session, you can always go to our YouTube channel and watch it. Whilst you're there, make sure you give us a subscribe, you share our videos, you like them, and also recommend the page to other people. My name is Roland. I'm one of the instructors here, and I hope you guys enjoyed this session of relays and input device and output devices. So yeah, I want to hit, my goal was by Thursday, we should hit 10,000 followers on TikTok. And you guys did phenomenal. Yesterday, we had a massive amount of following because you guys recommended the videos, you guys liked it, you guys shared it. And we are so grateful for you guys. We'll continue to bring you a lot of information and educational material. If there's anything specific that you want us to talk about, just leave it in the comment section below, or you can send us a message and we'll try and make sure we set it up. Once we understand all these, part of the series of what we're doing is we're going to go live to those electronic boards, and I'm going to be wiring them up based on different scenarios. And we are going to be toggling the relays using different input devices, output devices, and see how they behave. So I'm going to open the line. It's now 6:25 local time, Eastern time here in Canada. I'm going to open about 7 minutes to take questions if there are any. But if there are no questions, we can bring the class to a close. So it's question time. Get your questions ready. If you are able to wire it like this, just type a yes. If you couldn't wire it the same way, just type a no. It doesn't matter, we're still learning. So it's question period now.
So we must use different power supply, or is it the same?
Now, that was a good question. Here is 12 volts. Here is 12 volts. I can use the same 12 volts power supply to control what is here and control what is here. There is a catch. If I want to use the same power supply, I have to make sure that I look at the data sheet for the Maglock and look at the maximum power consumption. So let's say this operated at 1.2 milliamps, right? And I looked at this red LED, and this LED uses 300 milliamps. And when I come here and I look at this, because I'm going to power this, I pull up the data sheet for this relay that I'm using, and this uses, let's say, 50 milliamps. What I'm going to do is I'm going to take 1.2 and I'm going to add it to 3. So this is 1,200 milliamps. Oh, sorry, I made a mistake here. This is 1.2 amps. Yeah. So 1.2 amps is the same as 1,200 milliamps. So you take that and you add it to 300 milliamps. That gives you 1,500 milliamps, or 1.5 amps. Don't forget we have 50 here. So it's going to be 1,550 milliamps. So 1,550 amps. That is the power that is going to be drawn by all these devices together. So when I pick a power supply, I want to pick something like 2 amps, rated at 12 volts. So now with 2 amps, I'm able to power up this guy here. I'm able to power this, and I'm able to power that. I have enough current to go around. So that's a good question. You can use one power supply instead of providing separate power supplies for it. That's it. We're located here in Woodbridge, Ontario, and we're starting our online classes in April. So, like I said, we've already been picking a few of those who are going to have the opportunity. So far, I think we have 5 guys. I'll give you a few hints. There's some from Gambia. There's one from Uganda. I think there was the other one from Kenya, I think. So, yeah, we are looking. Just make sure that you've subscribed to all our channels. And these guys, we pick them from random places of our social media. One of them we picked from YouTube. We picked one from TikTok. We picked one from Instagram. So the next place we're going to go is Facebook and pick someone else. These guys who we pick, they're going to have the opportunity to participate in one of our live courses. After the course, they're going to get a certificate of completion. They're going to go through our online preview. So if you haven't and you want to be able to take some of our courses for free, just make sure you share our videos, follow us on all our platforms. This way you can be one of the lucky winners. If there are no questions, I want to thank each and everyone. Same time again tomorrow, 4 o'clock. Don't be late. I'll see you on the next one.